Good afternoon. Welcome to the webinar of the company Domat. Today we will go through a training on Domat IDE for beginners. Below the video you will find timestamps of individual sections, so you can jump straight to the passage you are interested in. On our channel you will also find short videos that are dedicated to specific instructions. For example, setting up proxy or secondary network. Further information can be found in the Domat IDE help. Or on our website in the FAQ sections. Domat IDE is a program used to program Domat PLCs. It can be downloaded for free on Domat CZ website in the download and software section. You can also find all older versions of the program here. The versions of the program also corresponds to the runtime version that runs on given PLC. Runtime is backward compatible, so if I have a new PLC with a newer runtime version, but the project is in older version of the program, it is not a problem. And I can upload the program as I please. If it were the other way around, an older PLC with older runtime version and a program is in a newer version of the IDE, IDE will first prompt me to upload the newer version of the runtime to the PLC. After that, it is possible to work without restrictions. Uploading the runtime takes only about 1 minute. If you are starting a new project, we recommend that you always take the latest stable version of the Domat IDE and update all PLCs to it. If a project has been running somewhere for years, you probably wouldn't want to update all PLCs, so you can download the relevant version of the Domat IDE and continues with it. There are always release notes available for download for individual version, where you can read about their new features and what fixes are there. So if I have some old software and something is not working properly, I look at the notes for the latest version to see if it has been fixed, and upgrade would help. Alternatively, I can report the error to the technical support. I can have all versions of Domat IDE installed on my computer at the same time. When I start the program, it asks me which version I want to run. If I open an existing project, it will automatically open in the correct version. If I don't have it installed, the program will notify me and I can install it, or I can open the project in newer version of the Domat IDE. Just be careful, if I open it in a newer version, you won't be able to be opened in the older version. The project is automatically saved with each compilation. On the system and the controllers page, we can see that company Domat has two series of controllers. The red ones with the mark designation are compact, which means that they have a fixed number of inputs, outputs, and communication channels. The white wall series are modular, which means that I have a basic unit and I connect expansion cards with inputs, outputs, and communication channels to it. In terms of performance, both platforms are identical, so designers usually decide based on the resulting price for the mix of inputs and outputs, and possibly based on how much space they have in the cabinet. For example, the Mark MX.3 offers me a lot of inputs and outputs for a great price, but it takes a lot of space. The wall series is more compact. When we click on the Mark series, we can see a clear table of all currently sold models and the number of their inputs and outputs. Even lower down is a link to another table where we can also find older, no longer sold models. In the table, they have a black text. Current models are orange with a link to the catalog. Some of these controllers had hardware with lower performance and therefore do not support all functions. See the table. The latest version of Domat IDE that supports them is 2.4.0.24. We can also find the column of the minimum version of Domat IDE. So if I have a program in the old Domat IDE and I want to add a new PLC, I have to check that the given version of Domat IDE supports it, and if necessary, update the program. If we look at the overview of the whole series, we can see the basic unit W750-8101. Another model is 8102, which also has a built-in serial communication line. Then there is a model 8112 on offer, which also supports .NET drivers and can therefore communicate with Dykins and Hauser devices, and also use the text parser and file driver functions. The last model is 9301, which is compact. It has fixed mix of inputs and outputs and can be expanded just like the Mark series PLCs via modbus or TCP modules. The offer also includes discounted sets of PLCs and expansion cards marked WCO, WCO.com, WCO.com.2, WMX, WMX.com, and WMX.com.2, which have a mix of inputs and outputs similar to the PLCs of the Mark series, namely Mark MX.3 and ICO 205.2. The installation of Domat IDE doesn't require administration rights or other supporting frameworks, so it should run without problems. During it, you can check the installation of the demo version of the Domat runtime. It is actually the same process as running in PLC. So if I want to try the program, but I don't have a PLC at hand, I just need to start the mod runtime with the icon on the desktop, assign it to the program, and work with it with real PLC. I can upload the program and configuration to it. I can start debugging and monitor the values of the variables. The demo version means that it runs for 20 minutes and then stops. I can close the window and start it again. I don't have to upload the program again, it remembers everything. Some customers have specific requirements and therefore use Domat runtime on their computer. You can purchase the full version of the program, but the demo is enough for regular testing. If you have multiple versions of Domat IDE installed, the program will ask you which version to run. We will choose the latest one. We can change the environment to the dark color scheme or the language. In order for the language to change, you need to turn the program off and on again. Now we will create a sample project. So file, new solution, I choose some name. The program will create a folder and all the necessary files will be saved in it. If I want to send the project to someone, just pack the entire folder and send it. Next comes the question of simplified or full mode. For beginners, I always recommend simplified. You can switch to the full mode at any time, but you can go back. Full mode allows you to program in the ST language, have multiple PLCs in the project, or use profiles and history. Simplified, on the other hand, automatically turns on global variables and assigns newly created programs to run on the PLC. So as I said, start with the simplified, and when you hit its limit, simply switch to full. To switch, just right-click on the project and select Switch to Full Mode. In the left column, we see our complete assembly. In the System tab, I will have one or more PLCs, their channels and devices, data sources and graphic terminals. Next are executable projects, where all programs, functions, blocks, and possibly libraries will be. The last third is HMI projects, where we will create a graphic or text diagram that we will use for terminal or web server. In the right column, there are always the properties of selected elements. So for example, if I click on a PLC, I see its properties. In the middle, we have the main window, where we will create our own programs, graphics, and so on. Below is a window with tools such as port monitor, graphs, and compilation results. If you close a window by mistake, you can call up the relevant window by clicking on the View menu. Similarly, you can reset the window layout, with the tools and reset layout. Now we will assign the PLC to the project. By default, all PLCs have static address of 192.168.1.10. For successful assignment, you need to set up your PC to static address from the same range. So for example, 192.168.1.1. In Windows 11, you can click like this. Right-click on the network. At the bottom, specify network settings. I will select the correct adapter and click on the arrow on the right. Other adapters options. Here I will select the IP version 4 protocol and switch from DHCP to static, which I will fill in together with the mask. Nothing more is needed. I will confirm OK and close all the windows. Now I can right-click on the PLC and select Attach PLC. I have a choice of UDP broadcast, which will scan all network cards in the computer. There is also the option to use deploy parameters. I will use this option when the PLC is on another network and I can access it, for example, via a public IP address. The last option is manual. I choose this when I don't have the PLC physically at hand yet and I want to prepare the project in advance. I wouldn't choose the PLC from the list. So now we will choose the first option. The login details for the PLCs are admin and RW as a password by default. If I have a PLC where I don't know these details, I can restore the factory settings by turning on the init dip switch and then restarting. So we will leave the default and click next. Now scan will take place. If I have a runtime running on my computer, it would also appear here at the localhost address 127.0.0.1. The scan will find the PLC. We can see the address, name, and a runtime version. If it's older version than the IDE version, a warning in the form of a small triangle will be displayed. The PLC can be assigned, but the Domat IDE will not let me upload the program until I update the runtime version on the PLC. It's a simple operation. We will show it later. Now we click next. Check download configuration so that the PLC properties are filled in the column on the right. If you get an error in this step, it's usually a problem with wrongly configured IP address on your PC. Check the settings and repeat the assignment process. If successful, we will see the download status at the bottom left. If we need to update the runtime, we right-click on a PLC operation, and upload the RT. It will show us a warning that we should not disconnect the power during the process. So we click OK and wait a minute or two. The status again is at the bottom left. There are 3 independent memories in the PLC: configuration, runtime, and program itself. So for example, if I change the address, I upload the configuration, and there will be no effect to either the program or the runtime. Similarly, if we need to update the runtime, I upload it, and there will be no change either to the configuration or the program. In the right column, we already have the information about the PLC filled in. At the very top, we have the name and device identifier. Then there are the parameters for connecting to the PLC. As we said, the default name and password are admin and RW connecting parameters. Here is the IP address where the Domat IDE programs connects. So if we are on a local network, the local PLC address will be there. However, if we have the PLC connected via public IP address, the public one would be here instead of the local one. Alternatively, we can switch to the connection type to proxy and connect to the PLC via a proxy server. Detailed instructions can be found on our web page. If we have the project in full mode, we can use the profiles and simply switch between the individual connection types by selecting the profile. Date and time settings. Here we can enter the NTP server, which the PLC will synchronize its time. Advanced network configuration. Here we find the settings for the secondary network card. By default, both cards are configured as switch. Everything is sent to everyone. If we turn on the enable, like this, we can set the secondary network card to a different network. Here is marked as at the X2. The primary network card is marked as ATH-X1. Similar descriptions can be found also on the network ports. In wall series, the primary is X1 and secondary is X2. In the mark series is ATH 0 and ATH 1. If the PLC has access to the internet, it must be always connected to the primary network card, so ATH 0 or X1. Below we find the proxy settings, user role settings for accessing the PLC. If the PLC has text display, we can assign a template to it. And at the very bottom, you can choose a template for the web server. For example, if I wanted to change the IP address of the PLC, I would change it in the network settings section and right click on PLC and select PLC operations and PLC setup and upload the configuration to the PLC. Other options are download the configuration and reset to factory defaults. I would leave the reboot the PLC at finish checked so that change would take effect immediately and click next. A table like this will pop up with an overview so that I don't accidentally slam the door in the event of remote connections. So we will confirm. Now the PLC has new IP address, so I can either change it in the connection parameters or I can reassign the PLC and it will change automatically. So we have assigned and set up the PLC. Now let's look at the inputs and outputs. If you are working with the PLC of the Mark series, it's easier. A channel will be automatically created and you will find inputs and outputs module on it. So I just click on it and name the individual items as I like. For example, temperature and outputs. Some PLCs of the Mark series have switchable analog inputs. They can measure resistance, voltage, and current. To measure current, in addition to changing the program, you need to turn on the dip switch for the given input. When using a temperature sensor based on PT1000, be careful about correct settings. If I leave the analog type as a resistance, then the resistance to temperature transformation and the type PT1000 are needed. But I can set up the input type directly to PT1000. Then I have to switch the transformation to linear and set the K to 100. If I leave the resistance to temperature transformation, the result would be transformed a second time and it would show nonsense. When changing the input type, you need to upload the configuration to the input-output module. So right-click on the module and select Upload Module Configuration. Click Next. If I change the transformation, I need to select cold restart when uploading the program to the PLC. You can find more information in the article Analog Input Settings on our website. You can also find the default transformation settings in the help for the given module. So for example, here I have the RxCO, so I can press F1 and click on it. And here you can see the default transformations. Now I will attach the wall PLC For wall type PLC, one more step is needed. After clicking on the channel, you can see that it uses KBus link, which is an internal bus to which expansion cards are connected. Now we only have one card here, it's power card, that is permanently connected to the PLC. It can supply up to 1.7 amp of current for the other cards. If I were to connect, for example, 30 cards, it would probably be not enough, and the program would warn me that I should add another power card. You can find more information about this in our designer's manual. I have 4 expansion cards connected to the PLC. Also, the very last one is always the terminating card, which is needed to terminate the bus. Now we will detect the cards. So right click on the channel and detect terminals. A message will appear that the PLC will switch to the commissioning mode, but I have checked return the current state while finished, so it will automatically switch back afterwards. Now I see my 4 cards. They are highlighted in red because I haven't added them to the project yet. Some cards have multiple prototypes. For example, the first card was detected at S750-530, but I can also select 750-1515. Just look at the top edge of my card and I see that it's type 1515. Anyway, they are similar cards. Both have 8 digital outputs. They only differ in the number of signaling LEDs and the number of terminals. So in the end, it usually doesn't matter which prototype I choose. So I will select all and click next. If I also have a card with a serial port 750-652 in the assembly, it is best to put it at the beginning because the delay of the KBus link is added to the delay of the serial line, and therefore some devices could have a problem with communication, and I would have to increase the timeout on the given communication channel for proper function. So now we have added cards. I can click on the last one, 451 for example, and I can see that the type is AI, which is analog input, and I have a temperature sensor physically connected to the first position, so I write the temperature there and confirm it with enter. Now we can upload the program to the PLC. In the top bar, the buttons change depending on the elements I have selected. If it's PLC, I see build solution and deploy solution. Domat IDE always compiles the program before uploading. So if there is an error, it displays it in the result window at the bottom and the program does not upload. So I don't have to do first a build and then upload. I just need to click upload. Here I can select what I want to upload. I can choose just the program or just the web. Alternatively, if I have touch terminals in the assembly, I will also see them here. The online changes option does not restart the program. After loading the program, it continues in the next program cycle by executing newly loaded code with the current values of the variables in the RAM memory. So I click OK. After loading the program, this table will pop up. I can choose warm or cold restart. Warm means that the values of all my variables remains as they are. Cold restart means that values of all variables are set to the default values. There is also a choice of PLC run mode. Full run is normal operation. Evaluation only is when the PLC program is running, but communication with the modules is not running. Communication only is when the program in the PLC is not running, but the communication with modules is running. And finally, commissioning mode. There is also check mark to remember last used. If you check this table will stop being displayed and the given options will be always used. This settings is valid until the IDE is turned off. When the IDE is restarted, the table will be displayed again. If I need to do a cold restart but I don't want to lose the variable values, how do I do it? I right click on the PLC and select the retrieve variables with the wizard. Now I have the option to set it as a initial values, add to variables collections, or just to write it to variable browser. So I select initial and confirm OK. We have uploaded the program. Now we can start debugging mode. So I will click here. Now we are connected to the PLC. It will show us the new window, system status. We can see the time on the PLC and fix it with right click, time setup, and click OK. We can see the uptime. We can see the state of the PLC. We can see memory. We can see when the program running there was created and who did it, and if it's the same version as we have in our program. We can see channel statistics. The error rate can indicate a problem, for example, swept cables with modbus. The last line shows us how long one program cycle takes. Currently nothing is running there, so we see thousands of seconds. With complex programs, we can see a second or even two. So we have to take into account that if I press the button that is supposed to switch on the output, the reaction can take one whole cycle. If you have debug mode on, some values are grayed out and cannot be changed. So you must first turn the debugging off again. If we look at the variable browser, we can filter by name. So I can type temp and we should see the value. Right now here we have 26 degrees. When I want to connect another device to the PLC, first I need to add a channel. So right click, first stop debugging, right click on the PLC and add channel. We can name it modbus, select protocol, modbus. We can select TCP or serial. Because the wall PLCs have switchable serial ports, we need to specify the type as 485. Now, if the device is already connected and it's from Domat, we can use the auto detection function. The PLC will find it and add it. I can also add the device from the library. The library contains only Domat devices, input and output modules, converters, room controllers, and others. Some devices have multiple prototypes. For example, the controller UI010. I can add the specific prototype or the generic one UI0XX, where there is a complete information from the entire modbus table. I confirm OK. When I click on UI010, I can see that only temperature and humidity reading is prepared. If I need other data, I can either edit the given device or I can use the generic UI0XX prototype, where there is a complete information from the entire modbus table. If I want to add third-party device, I select Add Device. I can name it. I can set manufacturer, model, version. I can set address. Then I can export it or add it to the library and share it with colleagues. Now I will click and add the group. The group will be for reading. Starting element 1, for example, quantity, for example, 1. I can select the function. Now I can add data point. So add data point. Also I can name it. The group is read. Set to length to 2 in case of integer. Similarly, for writing, I would add another group. It's for writing. Starting element 1, quantity 1. Here I would select, for example, F16. And again, add data point, assign group, this time right, and change the type. Set length to 2 and set right offset gap also to 2. This is how you would fill the data points according to the manufacturer's modbus table. Sometimes it can be hassle when the manufacturer does not state what functions the device supports or what type the data is or if the bit order is reversed. So try it or send us a question to support mail. Adding an mbus device is similar to modbus. I will add the channel, name it mbus, select protocol. This time the port would be 232 because it is used by the mbus converter Domat R095 or R096. Now I can let IDE automatically search for devices. The search is done either by primary or secondary address. Or I can add empty device and insert a group for reading similar to modbus and add data points there. Sometimes it can happen that the automatic search will find the meter, but the variables are not the ones I need. So you can use the port monitor function in IDE, select mbus channel and start recording. When I get the response from the meter, I can copy it into some translator and it will show me other variables that were not added by the automatic process. So I can edit the variables to read to the ones I need and use the diff and with properties. Now we will create a basic program. I will open main. I can see the columns on the edges where I can add variables, whether existing or newly created. The canvas size can be adjusted. First, we will try to control some outputs. So I will switch to FAPLA, Box Explorer. Here is the library of basic blocks. As you can see, there are blocks for analog, digital, and logical operations. I want to use a generator, so I will type the gen. And I want pulse generator, so I will drag it there. When I press F1, I will get the help for this specific generator function block. I can see the data types of inputs and outputs, a description of this function, and also there is an example of use. Some blocks have multiple similar variants, so it is a good idea to check the help to make sure I have the right version. Below in the results, I see the error. The project cannot be compiled. Domat IDE requires that all visible inputs of function blocks are connected. Here I can see that I have an unconnected enabled input. This is the block's permission to run. I want the block to always run, so I just need to make the input invisible. So I click on the block and uncheck the visibility of the enable input on the right. Now when I compile it, it goes through without errors and the block changes color from red to blue. Now we will add some outputs, so I will right click on the right column, global variables, and insert existing variable. We can choose, for example, DO1, and we will pull the wire from the output. Just for fun, we will also add DO2. So again, existing DO2, and we will pull the wire from the negated output. I will upload the assembly and confirm. So everything was successful, so I can start debugging. So now I can see the current values. Diodes on the output card will also flash. So stop debugging. Now I will right click on the left column, global variables, insert existing, and I will add the temperature. Now in the FUPLA blocks, I will find the GT block, which is greater than. And for example, if the temperature is higher than 27 degrees, I will turn on the AC. So I will turn off the visibility of the input too, and I will type the 27 here. And to the output, I will connect, for example, the O3. Deploy solution. Okay. Okay. Start debugging. So I can see the current temperature is less than 27, so the output is false. When I put my finger on the thermometer, the temperature rises and the output changes to true. If I don't have access to the temperature sensor and I want to try out the function, I can adjust the value in manual mode. I right click on the temperature and select manual mode. I check the manual mode and confirm. The value has turned yellow. Now I can change it. Until I turn off manual mode, the value will remain fixed. Similarly, I can put the entire block in manual mode. I can turn it off again from the program. So I leave the manual mode unchecked and click OK. Or I can turn it off from the variable browser. I can filter by the type and uncheck it like this. Manual mode remains on even if I upload a new program and perform warm restart of the PLC. Even if I disconnect the PLC from the power and then turn it on again, it is cancelled only by the cold restart. Now we will create our own function block. So I will right click on subfolder of the executable project and add function block. Some name. I usually show the is it odd block in the training, so we'll enter it. I will double click. In the left column, we will create the input. So variables, create input. Integer, okay. On the right column, we will create output. So variables, create output. And it will be bool. Now some logic. Our block should return the true if the number is odd. So first we will add the mod block. This block returns the remainder after integer division. So input to the in1, turn off visibility of in2 and type 2 here. Now we will compare if the result is 0. So EQ block, output to in1, invisible in2 and type 0 here. Now our block would return true if the number is even, since the remainder after integer division by 2 is 0. So at the end we will add a logical negation, not. Like this. Now we will check show in Explorer and build solution. Everything is fine. Our block will now appear at the top of our block library. From here we can drag it to our main program. We can do this with multiple copies. We can see that in addition to the input and output, N and NO have been added to it. This is the run enable and output enable. Domat IDE adds them to all blocks. We don't need them now, so we can turn them invisible. And now we have only input and output. We can control the output, for example, the O4. So global variables existing DO4. And we can connect the temperature to the input. I will click build. And we can see that we have error here. The block is red. And here we have the error. Expression real is not compatible with the input of integer. And we could edit our function block, or we could use another block to int. To transform the real to integer. So if the temperature is odd, DO4 will turn on. We can deploy. And start debugging. We can see the current values. We can simply copy programs and function blocks between projects with the classic Ctrl+C and Ctrl+V. For more advanced work, you can put blocks in the library and share it with colleagues. Library blocks supports versioning and will offer to replace the blocks in the program when a new version is released. If I change the logic in my block, it doesn't update automatically. I have to delete it from the program and add it again. So that was a simple example of a program and a function block. Now we will show how to create a graphic template. So stop debugging, click on the solution, and right-click on a subfolder of the HMI project. Add new HMI template. We will make a template for a web server, so we will call it a web. A display type graphic, template type PLC. For the web server, we will use the PLC. For touch panel, mobile application, or Domat visual on a computer, we would use the terminal. It is not possible to assign terminal template to a web server or PLC template to a terminal. More information can be found on the page on our website. You will find there, among other things, information on how to use one template for both the web server and terminal, or how to simply display information from other PLCs on the web server. So the template is created. When I click on it, I see the page resolution on the right. There are different resolutions of terminals and mobile phones prepared there. There are different options for adjusting the size on all display platforms. So it's more about the aspect ratio and whether the template will be in portrait or landscape. When I click on the page, I will see the properties of the page. I can put an image on the background. I can allow access to it to only selected user groups. I can nest a text or graphics template to it. At the top, we can see that the buttons have changed. Compile and upload are smaller, and the rest of the space is taken up by icons for aligning elements in plane, in a column, and so on. If I want to use images, I have to add them to the project first. When we click on the sources, we can see a few prepared images. We can insert more by right-clicking on the sources and selecting Add an Image. You can download the Domat symbols image on our website. After installation, it will be unpacked into the C folder, C apps, Domat symbols. There are various folders for heating, cooling, pumps, and so on. Domat IDE supports animation, vector, and raster formats. So we can browse and we can select multiple images at once. The images are copied to the project folder and I can use them now in the template. Now we will add graphic elements to the page. I will switch tab to HMI objects. We can see text and graphics elements there. We are making graphic templates, so we will expand the graphics. For all elements, you can customize the font size, color, background color, rounded corners, and so on. This is only default appearance, and your graphics can look completely different. Alarm is an element that connects to the alarm block, and by tapping on the element, I can confirm it or reset it. The default is bell icon, but it can be completely edited like the other elements. Alarm point is the same, but it can connect to a block with only one alarm input. Analog setter, it's for adjusting analog values. I can adjust the values with up and down arrows. The step size is adjustable as well as the images for up and down arrows. Datetime indicator and datetime setter is indicator and setter for datetime data type. Chart will show a chart, but this functions only on web server, not on Domat visuals on PC or mobile phone. Digital indicator, it's a digital value display. I can edit it again. So for example, value 0 will be an image of a standing fan, and value 1 will be an animation of a spinning fan. A digital setter is a digital value adjuster. We also have digital setter buttons. It's similar, but all options are visible and active is highlighted. Otherwise, I can connect all digital setters to integer and map individual values, for example, as a running mode. So, for example, 0 is heating, 1 is cooling, and 2 is off. Another one is digital setter combo box. When you click on it, it will open a list from which I can choose the value. Image. If I want to place an image without a function somewhere, for example, company logo, link, it can link to another page, for example. On the web server and mobile phone, it can also be used for an external web address. For example, inverter, user manual, or online foldbox, and so on. Pop-up will show a small window. For example, if I want to control 4 boilers on the same page, and at the same time I want large buttons, so it can be controlled even with gloves on. So I can make one button for boiler 1, boiler 2, 3, and 4, and after clicking on it, small window would appear where I can set the boiler parameters. When I click on boiler 2, the first one hides and the boiler 2 settings appear. A new template must be created for the panel and it has to be assigned in the pop-up settings. Progress bar is another display of the value. I can simply see that the process is approaching the end, even across the entire hall, so I don't have to decipher some numbers. Rectangle, a simple square for highlighting, slider, similar to progress bar, but now there is a slider which I can change the values. The advantage compared to analog setter is that I can set a small steps for precise adjustments, but at the same time I can immediately move from minimum to maximum. Template, I can create sub-templates and insert them into the main template. When I then edit the sub-template, it changes everywhere. Text, simple text without functions for labels, etc. Text setter is input field for the string data type, but I can also map it to integer and use it to enter analog values. After clicking on the field, the keyboard on the mobile phone or terminal will appear and I can write directly. Next are 3 types of time programs for bool, integer, and real. They look like this. And finally, we have the value indicator for showing the analog values. So now we will add few digital setters and connect them to the DO1, DO2, and DO3. We can add value indicator and connect it to the temperature. We can add the text. We can add the units. Now we will assign the template into the PLC. If you want to change the access rights, double click on the PLC and HMI user rights are here. Now we can deploy it and we have the web selected. So we click OK. It takes a little longer because the PLC also uploads scripts and fonts for correct functions of the websites. So now we can open the browser and enter the IP of the PLC. And now we can see it's connected and it's showing us the data. At the top of the page, you can adjust the page magnification, expands according to the width, set it to 100% or fills the screen. Next to it, we have page guide. Now we only have one. Even further to the left, there are graphs. I can press the Control key on the keyboard and click on the variable to select multiple elements and click on the graph. If we have the history saving enabled on the PLC, we will also see historical data. Otherwise, we have to turn on the oscilloscope mode and the data will start to be displayed. You can set the time range and download the data in the form of an image or CSV file. Now we are on the web server as a visitor. If we log as an admin, by default, the name is admin with capital A and password is small a. We will see more options now. The first one is alarm log. It will show us when and which alarm occurred, who confirms it, and so on. And next is system log. It shows us information about the PLC. And the next is settings. You can change the network, proxy, or database settings. Now I will show you the template for terminal. First, I will add the terminal. So system, add terminal. The choice is external ref 2.2, which is usually used when I just want a general terminal, for example, a mobile application. Then we have HT 102 and 104, which are older text terminals for which I would create a text template. Then there are HD 200 and 300, which are graphical terminals with touchscreen. And also controller as external web server, which I would use if I want to display data from other PLCs on the web server, or if I want to use the same template for the terminal in the web server as well. As I mentioned, you can find more information on the page. How is it with those templates? So we will choose the external and click OK. I will click on the arrow, terminal channel, and right click, assign device, click on PLC and click OK. There can be more PLCs or other data sources. This procedure would be the same for HT300 terminals and others. Now we will create a template, this time graphics, but for terminal. Now we can assign it to the terminal. So click on the terminal, device template, this terminal. We can copy the entire page from the template for the web. Make sure you have nothing selected. So I'll just click in free space and click right, copy, terminal, paste. So I have the same page as on the web server. Now you can preview the template, right click on terminal and show preview. This is how it's gonna look like. And we will go to the second page and now we can see it's connected to the PLC and showing the information. We can export the definition for mobile phone by right clicking and export definition. And it will create the zip file, which then can be sent to the end user to control the PLC. If you want to save historical data on the PLC, you need to switch the project to full mode. So right click on the project, switch to full mode. Do you really want to switch? This is a one-way ticket. Click OK. At the bottom, we can see the history. So right click, add new history. There can be multiple different histories on the PLC. So we can click on it and turn it on with the check mark here. We have a choice of synchronous or asynchronous. In the first case, you just need to set the storage time period. By default, it's 1 minute. We don't need to fill in any other variables. If we want asynchronous, we also need to map the variables for permission and writing. We can also insert our own timestamp into the historical data. The PLC can store 40,000 integers and they are overwritten starting from the oldest. So if, for example, I save one integer every minute, the history will last me a month. If every hour, then 2 years. It also depends on the data type of the variable. I will say more booleans than integers and less reals. We can add a variable to the history from the variable browser. Add to history. Okay. Now when I click on the history, I can see that it has been added to my history. Now I can deploy the solution without the web. We don't want to wait too long, so okay. And the PLC will start saving the data. I can then download the history from the IDE program. So right click, download history. I can select the time period and the UTC or local time. The CSV file will be saved in the project folder. I can also download the history from the web server as we showed in the web server template chapter. I also want to show you what a real boiler room project looks like. If you want this file, just send us email at support@domat.cz. So this is the project. So right at the top, I can see profiles. I can easily switch the address where the IDE connects to the PLC depending on whether I am in the internal network or remotely. Then I click on the PLC. I can see it's assigned to the Windows runtime. On COM3, I can see MXIO module with inputs and outputs. All the inputs and outputs are described with the name. The next channel uses COM4. Since the mbus protocol is selected, it will be via R095 or R096 converter. There are 5 meters on the channel. According to the description, probably gas meters. Next we have a data source, which is a different PLC, and we are getting data from that PLC. Next we have a HT300 terminal, and as you can see, it's getting data from data source and from the PLC. In the projects, we can see various custom function blocks. When I click on one, you see that it's good to use notes so that the colleague to whom you send the project has an idea of what he is looking at. We can show the program. Here there are multiple instances of custom function block. When you click on it, it will open. And here there are some other nested custom blocks like this one. So we can click on it. And finally, we have the basic function blocks. When I double click on the PLC, I can see that all the programs are assigned to run on this PLC. And also, as you can see, there are a lot of graphics here. These images are for the background. We have 2 templates, so we can open one. This is a boiler room. We can see that it's using a background image, and all the informations are put on top of this image. The last page here is the text menu. At the very bottom, you can see the history, so you know this project is in full mode. So now you have the basic understanding of working in Domat IDE. Thank you for your attention and see you next time.